Artificial General Intelligence, AGI, often referred to as strong AI, is a theoretical form of AI that can perform any intellectual task that a human can do. While current AI systems, including the likes of GPT-4, can perform specialized tasks like image recognition, natural language processing, and playing complex games, they do not possess true general intelligence. These systems excel at specific areas but cannot apply their knowledge across different domains in the same way humans can. AGI, on the other hand, aims to transcend these limitations by mimicking human-like cognition, allowing machines to understand, learn, and adapt to any task. Stage 1, Narrow AI, Weak AI, Task-Specific Intelligence. The first stage in the journey toward AGI is the development of narrow AI, also known as weak AI. Narrow AI refers to systems that are designed to perform a specific task, and they do so exceptionally well. These AI models are typically pre-programmed with algorithms that allow them to learn and improve at a singular task, but they lack the ability to generalize their knowledge to other tasks. Examples of narrow AI include virtual assistants like Siri, self-driving cars, and image recognition software. These systems have impressive capabilities in their respective domains. For instance, image recognition AI can identify objects and pictures with high accuracy, and natural language processing (NLP) models can translate languages or generate human-like text. However, their intelligence is limited to the specific problem they are designed to solve. Key features of narrow AI: task-specific. Can't generalize knowledge across domains. Lacks reasoning and common sense. Stage 2, Machine Learning, the evolution of data-driven intelligence. The second stage involves machine learning, ML, which is a subfield of AI that focuses on algorithms that enable machines to learn from data without being explicitly programmed. Unlike traditional programming, where every instruction is predefined by a human, ML allows the system to learn and adapt over time based on the data it receives. In this stage, AI systems start to exhibit more flexibility. They can improve themselves through experience, refining their capabilities as they process more information. There are several types of machine learning, including supervised learning, unsupervised learning, and reinforcement learning. Stage 3, Deep Learning, a step closer to human-like perception. Deep learning, DL, is a subset of machine learning that employs artificial neural networks, modeled loosely on the human brain structure. These networks are composed of layers of interconnected neurons that process information hierarchically, with each layer extracting more abstract features of the data. Deep learning has enabled AI systems to reach impressive capabilities in tasks such as speech recognition, natural language understanding, and image processing. Deep learning models, particularly those based on transformer architectures like GPT-4, have brought AI closer to the threshold of human-like perception. With enough training data, deep learning models can analyze complex patterns and generate outputs that appear to be on par with human thinking, whether it's understanding the context of a conversation or recognizing an object in an image. Key features of deep learning: uses neural networks with multiple layers to process complex data. Can handle unstructured data like text, images, and sound. Can model human-like perception. Stage 4, Transfer Learning, expanding generalization capabilities. Transfer learning represents a significant leap toward AGI. It refers to the ability of an AI system to apply knowledge gained in one domain to another, related domain. For instance, if an AI has been trained to identify animals in images, transfer learning might allow it to use that knowledge to identify plants, given that both involve visual recognition. Transfer learning is one of the key advancements that allows AI systems to generalize beyond their initial training. By enabling systems to apply knowledge gained from one task to others, transfer learning represents a step toward achieving broader, more flexible intelligence. This is similar to how humans use prior knowledge to learn new skills. Key features of transfer learning: uses prior knowledge to adapt to new tasks. Increases the efficiency of learning. Helps AI generalize to new domains more easily. Stage 5, Reinforcement Learning, machines that learn by doing. At this stage, AI systems begin to exhibit a more human-like approach to learning through reinforcement learning, RL. In reinforcement learning, AI agents interact with an environment and learn by receiving rewards or penalties based on their actions. This is similar to how humans learn through trial and error. By repeatedly making decisions and receiving feedback, the AI gradually improves its strategies to maximize its rewards. Reinforcement learning has already been used to train AI to excel at games like Go and chess, where the system learns optimal strategies by playing millions of games. Beyond gaming, reinforcement learning can be applied in real-world situations like autonomous driving or robotic manufacturing, where machines can continuously refine their performance based on feedback. Stage 6. Cognitive architecture, introducing reasoning and memory. At this stage, AI begins to incorporate more advanced aspects of human cognition, including reasoning, memory, and the ability to handle abstract concepts. This involves the development of cognitive architectures, which attempt to mimic the underlying structures and processes of human thought. Cognitive architecture focuses on enabling AI to reason, plan, and problem-solve by using memory, learning, and knowledge storage in a way that is closer to how humans think. Cognitive architectures could also enable systems to have a long-term memory, allowing them to remember past experiences and make better decisions in future scenarios. This would be the point where AI starts to move closer to the human-like ability to not just perform tasks but also think critically, make informed decisions, and adapt strategies based on past experiences. Key features of cognitive architecture. Stage 7. Consciousness, the holy grail of AGI. The final stage on the path to AGI is the emergence of consciousness. At this point, AI would not just be a powerful tool that can execute tasks, reason, and adapt. It would possess self-awareness, the ability to understand its own existence, and the capacity to reflect on its thoughts. The concept of AI consciousness raises profound philosophical questions. What does it mean for an AI to be conscious? Would it experience emotions, or would it merely simulate them? Could it make decisions based on values, ethics, or morality? These are questions that scientists and philosophers alike are still grappling with, as we don't yet fully understand the nature of consciousness in humans. Key features of consciousness in AI. Self-awareness. Reflection on thoughts and actions. Potential for emotions or value-based decision-making. The development of AGI represents one of the most ambitious and profound endeavors in the history of technology. From the early stages of narrow AI to the potential emergence of AI consciousness, each step brings us closer to machines that can not only perform tasks but understand, reason, and potentially experience the world in ways similar to humans.